Today I'll talk about heat energy calculation for various gases like monoatomic, diatomic and polyatomic gases. Here is the problem statement. How much heat energy is required to increase the temperature of 6 mole of each of the following gases by 40 Kelvin? Question number 1. Neon at constant volume of 6 liter, xenon at constant pressure of 10 atm, oxygen at constant volume of 0.40 meter cube, and methane at constant pressure of 1.2 into 10 to the power 5 Pascal. Now first is we have to know what is the relation of monoatomic and diatomic gases heat capacity. The heat capacity of monoatomic and diatomic gases. So monoatomic gases like helium, neon and argon, CV is 3 by 2 R. So 3 into 4.157 because R is 8.314, so divided by 2, so that is 4.157. So 3 into 4.157, so that is 12.47 joule per mole Kelvin. CP is 5 by 2 R, so that is 5 into 4.157, so that is 20.79 joule per mole Kelvin. Diatomic gas like oxygen, nitrogen, hydrogen, so CV is 5 by 2 R, so 5 into 4.157, that is 20.79 joule per mole Kelvin. CP is 7 by 2 R, 7 into 4.157, that is 29.10 joule per mole Kelvin. Now first, neon at constant volume. So gas is neon, process constant volume, moles N is 6, volume is V is 6 liter, and temperature change delta is 40 Kelvin, and CV 3 by 2 R, so that is 12.47 joule per mole Kelvin, and Q we know that N CV dt. So using the molar heat capacity of neon at constant volume, that is CV is 12.5 joule per mole, and if we plug all this, so N is 6, CV is 12.5 and delta is 40, so Q will be 3000 joule. Now next is xenon at constant pressure. So xenon Xc, process constant pressure, and then N is 6, pressure, P is 10 atm, and temperature change delta is 40 Kelvin. CP is 5 by 2 R, that is 20.79 joule per mole Kelvin. Q is NCP delta. Using the molar heat capacity of xenon at constant pressure CP, that is 20.8 joule per mole Kelvin. Calculation, so Q is NCP delta T, so N is 6, CP is 20.8 and delta is 40, that is 4.992 joule. Next is oxygen at constant volume. Heat energy calculation, so gas is oxygen, process constant volume, mole is that 6, that volume V is 0.4 meter cube, temperature change delta is 40 Kelvin. CV will be 5 by 2 R, that is 20.79 joule per mole Kelvin. Q is NCV delta T, so Q is 6 into 21.0 into 40, that is 5040 joule. And then methane, so that is polyatomic gas at constant pressure. So for molar heat capacity of methane polyatomic gas at constant pressure, CP is 35.7 joule per mole Kelvin. So here given data is gas is methane, process is constant pressure, moles N is 6, pressure P is 1.2 into 10 to the power 5 Pascal, temperature change delta is 40 Kelvin, Q is NCP delta T. Now if I plug all this, 6 into 30.169 into 40, so that is 8565.6 joule. Now here is the summary. So neon, so constant volume Q is equal to 3000, xenon, that is Q is equal to 4992 joule, oxygen constant volume Q is 5040, methane constant pressure Q is 8568 joule. That's it. Thank you.